All right, so this is week 3 now, and we're doing some heat loss through a wall, which is essential to doing complete house calculation. So this is one of the most common problems we'll face, and basically it's heat loss through a wall if you have a window. So I'll start by reading the problem. A wall made out of brick with R value equal 0.5, and added 2 layers of insulation with R value equal 0.35. Temperature inside 75 and 10 degrees outside. Question? Yeah.
So when you're doing the window,
Yeah.
if it states that the R value is 4.5,
Yeah.
is that for one pane or just the total window?
Total window, the complete frame. So let me, so we get the temperature inside outside. The wall is 15 feet wide, 8 feet high, and the window is double pane, 4x6, and has an R value of 4.5, and that's the value for the entire window. So when you buy a window, they sell to you as a whole until this is the R value for the complete thing. If you get asked a question, ask me loud because I want to be in the video so people can take advantage of that as well. Okay, so I'll draw the wall a little bit just to make things easier on me and can visualize it. Here's our window. And let's look. It's 15 feet and 8 by 8. That's the standard ceiling size. Sometimes higher, sometimes lower, but that is the standard. And window is 4x6, assuming it's this way. And we want the heat loss from the entire wall, including the window. So we'll start with Richard's favorite equation. Heat loss equal area times U factor times dt. And since we know that we have 2 components, this wall, we'll do the wall and the window. So it'll be Q for the wall, total Q for the wall, plus Q for the window. You agree? We'll start with one at a time. So Q wall equals area for the wall times the U factor of the wall times delta T. Okay? Let's find those components. So the area of the wall will equal to gross area minus window. So the gross area is 15 by 8 minus the window, which is 4 by 6. We agree so far?
Mm-hmm.
What is 15 by 8? 120. Minus 24. 96. What? Squared. Okay. So now we get the area for the wall. What is U for the wall? So we have resistances.
0.8.
So we will need the total resistance. So
With the window is 5.3.
no, we're not gonna talk about the window.
Just
We're only the wall. Yeah.
The R value is total of 1.2.
Say that again?
1.2?
Let's see. So the U factor for the wall is 1 over the total resistance of the wall, which equals to 1 over, what do we have?
0.5 and then 2 times 0.35.
0.5. I'm gonna go with my second grader because I don't wanna mess it up. 2 layers of insulation are value 0.35 plus 0.35. Just having this time we have 2 layers of the same insulation, we might have 2 different insulations, one on the inside, one on the outside. So this is going to be our total sandwich. And this is 1 over what? 0.7 and 0.5, 1.2?
Yep.
What is the total? what is 1/1 divided by 1.8? What is it? 0.833. I will stop at 2 decimals or 3 decimals. Joshua, question?
Where did you get that second 0.35?
Because we said here, 2 layers.
Okay, got
If
it.
we have 2 layers, it makes sense that we add more. And that will give you an idea. If you add some more resistance, you'll get more.
Is it all right if you drop the other three?
Huh?
Drop the other three, is that all right, or do you always wanna have two numbers? Where it says 0.
Yeah, it's okay.
It's got 8.
2 decimals is okay. And if you notice, this is less than 5, so it's not going to be a big deal. Okay, what about, so we got the area of the wall, we got the Q factor, we wanna do the delta T. That's very simple. DT, temperature inside. Is it inside, which is higher? Yeah, inside, minus temperature outside. So 75 minus 10 degrees. 65 degrees. That's pretty cold. So 10 degrees is not abnormal. It gets 10 degrees here a lot. And so I'm assuming it's 10 degrees outside, probably somewhere like in Boston, which is the coldest day of the year. So we got all we need now. So we can we go back and calculate all the heat loss for the wall? Yes, we can. So I'll use the space over here. Trying to economize space for the camera. So Q wall equals, what is the area? 96 times 0.83 times 65. What do we get?
5179.2.
That's BTU per hour. Okay, are we done?
No.
No, we need to do the window. So I'll do the window. Is it okay if I erase this part?
Hold on.
I think I know what my job's gonna be when I finish here.
We're good? Going once, going twice.
Let's see what hour.
Okay. So the area of the window, now we're doing windows, right? It's only one window. It is the same, so we have window, one window. We agree? Question?
Yeah, so pretty much like, there's Q, then there's a Q for the wall, Q for the window. Q for
Yeah.
the doors.
Then you add.
So you just add it and just window, or, alright.
Yeah. The most confusing part is people do the wall without taking out the window area,
Alright,
or forgetting about the window, or they add all the resistances together and say, okay, this is the entire wall, which is not the case. So it's not that complicated. But it's involved. You have to go upstairs. So area of the window is 24. Everybody agree?
Yeah,
You with the window,
4.5,
give it the R value. So
1 divided by 4.5,
you window, 1 over 4.5.
0.22.
That's a big factor compared to the wall. And DT is the same, right? So we'll go here and say, okay, since we got that, let's do Q. (24) times U times 65. What we got?
342.2.
343.2.
Okay, so now we can say we have Q for the entire wall equals
that,
Anybody got something different? What do you got?
343.2.
It's 7.1, probably it's decimal somewhere. I'm not gonna split here over like, one
I
BTU.
got 342.2.
Somebody turned their iPad into one, we have one more BTU. Okay, so Q all, 5179.2 plus 342.7. What do we get? Somebody?
552.1.4, that's what I got, I'm off.
552? I'll do it myself. I don't trust you guys.
552.1.
You have the numbers words here. 0.2 plus 342.7, 5521. 0.9. I will go and just say 5522 BTU hour.
Round it up.
Why?
So that's going to be our BTU per hour for the entire wall. And usually in a room, one wall or two walls are facing the outside. And we always do the walls that are facing the outside, right? Or sometimes it's facing cold partition. Let's say it's facing a garage that's not heating. You also will do that as well. So wherever there is a temperature difference, you do the calculation. And this is the basis for doing heat loss. You'll do the same thing at some point for the ceiling, right? And for the floor, but there is no windows, unless you have a skylight. That'll be a different thing. So this is for transmission heat loss, and next week we'll do infiltration heat loss, which we will find an infiltration rate and do another heat loss. Any questions? Clear? You can do it? Excellent. We'll see you in the home. All right.